Welcome to the labs for Module 1. As you can see, Lab 1 is going to consist of two different exercises. Exercise 1, metric conversions, which you can find in your lab manual. That is on page 1, as well as Exercise A, and that's going to be looking at locations. That is supplemental reading. You will only be able to access this information through the lab module. This is going to be a quick presentation where we introduce these topics, look at how to do some metric conversions, as well as looking at some basic information that we need for understanding location and finding absolute locations. So let's go ahead and get started with the information we need for exercise 1. So this is the measurement systems that we use in the scientific community, and there is a major difference between the systems that the majority of us are going to be familiar with from growing up in the United States versus what the majority of the rest of the world uses, as well as the scientific community. So even though we are mostly familiar with the English system, where we grew up using feet, miles, gallons, the majority of the rest of the world uses the metric system, where they're using meters and kilometers and liters. And for the most part, or I should say generally everywhere, the metric system has been incorporated into what is formally known as the international system, or it's the System International, known as the SI system. And so really that's what we're looking at. The differences between these systems, where the rest of the world, or specifically the scientific community uses, and the English system. And in order to get on the same page, it is important that we are able to convert between these two systems to need. But the point of this lab exercise is that you learn how to do some of these conversions yourself. So there are some great tools in the lab manual. I've provided an image that you can see here, but again, the lab manual helps you to convert from the international system to the English system and vice versa. And that is basically what the practice lab and your graded lab are going to be dealing with. It's going to be converting back and forth between these two systems of measurement. As you can see, this is one of the images that is a screenshot taken out of your lab manual that is showing you how to convert from the SI, the international system or System Internationale, to the English system. And you can see too that the general conversions are going to be able to be done through and by applying basic formulas. Centimeters to inches, or kilometers to miles, meters to feet, and vice versa. There is another image that will help you with converting back, or you can go ahead and divide these numbers as well. And so important is that it's showing us the difference between exact conversions and approximate conversions. And so for the sake of our lab, we are only going to be dealing with exact conversions. So when you are looking at the images, and assisting you to do these conversions, you need to be looking specifically at the exact conversions. Arguably, the most complex one is going to be the one where we're dealing with temperature, as that formula is going to be mildly more complex than the straight conversions of multiplying or dividing numbers when converting from the international system to the English system. So again, I have provided a quick example, and I'm going to walk you through some of these conversions very quickly. So if we have 14 centimeters and we need to convert that to inches, how do we do that? We're going to have to go up here and find the correct conversion, where we're going to be converting centimeters to inches. And so thankfully up here we can see that centimeters times however many times this will give us the inches, right? So we're going to come back down here, plug that in, 14 centimeters, multiply that by 0.394, plug that in here, is going to give us the correct amount of inches when we're converting. So you can see how that's been plugged over here, and that is going to give us 5.516 inches. What's also important is when you are selecting the answers for your practice and your graded exams is that we are going to be rounding that to the nearest tenth. So every answer is going to be rounded to the nearest tenth unless specified otherwise. So the correct answer for A is going to be that 14 centimeters is going to equal 5.5 inches. And so here we're converting temperature, and you can see that there are two different options. if we're converting from Fahrenheit to Celsius, you can go ahead and use this easy one down here rather than going Celsius to Fahrenheit. But you're going to go ahead and plug in the exact same numbers. So if we're converting 47 degrees Fahrenheit to degrees Celsius, we're going to go ahead and use this formula we have down here. So first off, because it's in the parentheses, if we're using our PEMDAS, we have to do all the equations within the parentheses first. So we're going to take 47 minus 32, and then ultimately we're still going to have to divide that by 1.8. So because we're doing this first, it's going to leave us with 15. And then we divide 15 by 1.8 once we've subtracted these numbers. That is going to give us 8.333 repeating. Again, we have to come back here and we need to round this to the nearest tenth, right? So that is going to be that first number down here, and that is going to round to 8.3. So the correct answer for your practice lab or your graded lab for figuring out what the conversion from 47 degrees Fahrenheit to Celsius is would be following these steps, and you would come to 8.3 degrees Celsius. Again, there is a ton of other helpful information that gives you a little bit more detail on the conversion systems as well as rounding to the correct answers that you can find in your lab manual. Again, that is exercise 1 located on page 1. Moving on to exercise A, that is going to be the supplemental exercise. That is where we're dealing with location. And in order to do that, we're going to need to learn the basics of latitude and longitude. This geographic grid, or what is known as the reticule, is made up of lines of latitude and lines of longitude. Any basic component to geography is going to be understanding the differences between your lines of latitude and lines of longitude. One way that I like to remember the difference is that lines of latitude, you can think of it as being flatitude, which means that those are the ones that are going to go around the world this way, so horizontal. Longitude, or being long, are the ones that are going to be moving around the world vertically. And so we have to use lines of latitude and lines of longitude in order to find exact locations on the globe. And that entire system, this geographic grid, that is what we refer to as the reticule. So all points expressed are in degrees, minutes, and seconds, and we will come back to that. Most importantly, though, that these lines of latitude are going to be references to angles from the most important line of latitude, being the equator. That's this red line that marks the 0 point. So these are angles north and south of the equator, or angles east and west of the most important longitudinal line, that is the prime meridian. That is also going to be this 0 point. So lines of latitude and longitude are going to be degrees east or west, or degrees north or south from these most important lines. In order to find absolute location, you are going to be needing to calculate where various lines of latitude and longitude intersect. And so here's another great representation showing you that angle between 30 degrees north of the equator or 90 degrees west of the prime meridian, right? So if this is the equator, degrees north is going up this line. So degrees north is going to find us this point, 30 degrees north of the equator. Or if we're starting here in the prime meridian, which is the 0 point when you're looking at lines of longitude, and you're moving 90 degrees to the west, you're going to find this point, or 40 degrees west. Or you can go the opposite direction again, you go 40 degrees east. And same thing, if we're looking at the equator, which again is this horizontal line that goes around the globe, the 0 point, we can go 30 degrees north, which is also going to be right here, or 30 degrees south, which is going to get us here. And so there's a very helpful video that you should take a moment, locate that, and go ahead and watch it. It does a really good job at breaking down how to use lines of latitude and longitude in order to identify points on the globe. It's also really important to note that when you are looking at absolute locations, the line of latitude is always listed before the line of longitude. So go ahead and take a look at that video before moving on with the rest of this presentation. Okay, so this is a mild practice exercise where you can take a look and try to identify the latitude and longitude of various points. So if we're going to start with trying to identify point A on this map, we always want to start with identifying where the equator and the prime meridian are located. Again, the equator and the prime meridian are always going to be those 0 points. They're going to be the most important starting points. So if we are trying to find point A, we are going to start with our line of latitude, that is our flatitude, our horizontal line. So that means even though there are these numbers on the equator, what we really are doing is we're looking for which parallel line we are going to get to. So our latitude is going to be 10 degrees, 20 degrees, 30 degrees, 40 degrees north. So our first number is going to be 40 degrees north, and then we need to find how far east or west it is of the prime meridian. So A is going to be on this left side. That is going to be our west side. So we now have to move west. So that is going to be 10, 20 degrees west. So we know that point A is sitting at 40 degrees north and 20 degrees west. And sure enough, you can see that over here. Same thing, if we're looking to identify point B, let's go ahead and start there. So once again, what line do we start with? We are going to start with our line of latitude. So moving from the equator, we're looking at our parallel lines. We are going to be going to 10 degrees south, 20 degrees south, and oh, look at that, 20 degrees south has gone too far, so we are going to ballpark this one at around 15 degrees south. Now let's find out how far east or west it is. So B, again, is on the left side of this hemisphere. So going along the equator, we are going to count how many degrees how many degrees west it is. 10, 20, 30, 40 is too far. So again, we're going to go ahead and ballpark this one at 35 degrees west. So we always start with our latitude first, then we write our longitude. So the ultimate point is going to be that point B is located at 15 degrees south and 35 degrees west. All right, moving on to Lab 2. Still a part of Module 1. This is going to be a supplemental reading. So go ahead and take another look at the supplemental reading that is provided to you in the modules that will help to explain what we are doing here. And I'm going to jump back up here. All points are expressed in degrees, minutes, and seconds. And so that is really what we're looking at right now. So jumping back down here and jumping into refining locations using our geographic coordinate systems. So we have here 10 degrees north and 170 degrees west. So this is more precise than just using 10 degrees north and 170 degrees west, which we had done in the previous exercise. So the reason that we have to do this is because this allows us to get that pinpoint accuracy for any place on the globe. But that also means that it is possible to write this incorrectly. And that's basically what we're going to be doing, refining locations. So whenever there is more than 60 seconds or more than 60 minutes, it is going to be labeled as incorrect. And that's the same thing, because you wouldn't say that there are, it's not 2 o'clock and 62 minutes, right? If it was 2 o'clock and 62 minutes, then it would actually be 3 o'clock and 2 minutes. So the same applies when we are going to be converting these degrees, because they are in minutes and seconds. And 60 rounds up to the next minute and the next second. Or, sorry, rounds up to the next minute and the next hour. And in place of that hour, that is where the degree is going to be changing. So if it was 10 degrees, it would change to 11 degrees. So that's what we're looking at here. So if there are more than 60 seconds or 60 minutes in a previous number, then we are basically going to subtract 60 from that number, add 1 to the minute or 1 to the degree, and then what we're left over with is going to be the final answer. And so that's why jumping up here, you can see how 130 seconds is not going to be accurate, right? And 86 minutes is not going to be accurate either. And if we're looking down here, oh, and there's a minor typo. This all looks correct because our seconds and our minutes are all under 60. So leaving a 60-minute or a 60-second is never going to be okay. It needs to be converted to 0. And you have to add that additional 1 to the number left of it, right? So that's either going to be adding a number to a minute or adding a number to a degree. So let's look at some practice exercises. And as we looked at before, 130 seconds is incorrect. So we have to convert this into an acceptable amount of seconds. So we're going to go ahead and start with this one and say that we know that 130 seconds is more than we need. So we have to subtract an entire minute, meaning we are going to subtract 60 from that. And that is going to leave us with 70 seconds. And we're going to take that 60, which is in essence an entire minute because it's 60 seconds, and we add that 1 minute to the degrees. So after our first step, we are then left with 10 degrees, 41 minutes, and 70 seconds. But hey, that's still wrong because 70 seconds is still more than you'd find in a minute. So we're going to do this process again, subtract 60. That leaves us with 10 seconds, but that means we also have to add a whole another minute to our minutes. So the correct answer for the first half of our coordinate is going to be 10 degrees, 42 minutes, and 10 seconds north. Same thing, we have an issue over here. 1 second, that's perfect. We don't have to adjust that. But 86, that is an issue for us. So what do? We have to subtract 60 minutes from our minute. That is going to leave us with 26 additional minutes. But what do we do with that minute? That is, in essence, that hour. 60 minutes is an hour. And we're going to add that number to the front here to the degrees. So ultimately, it is going to be 171 degrees, 26 minutes, and 1 second west. So the correct answer is going to be this down here that is highlighted after we have refined these locations. This is going to be one that you can practice by yourself. So go ahead and pause the video here. The answer will be provided for you as soon as you hit play. All right, let's go ahead and see how you did. So here is the correct answer. Remember that we have to subtract 160 from the minute if it is too much. So we take 170, subtract 160, leaves us with 110. Turns out that is still too high, so we have to do that process yet again. Once we have done that twice, we are going to be left with 50 minutes, but that means that the 2 hours in essence that we have had to subtract is going to be added to our degrees. So we are going to be left with 22 degrees, 50 minutes, and 13 seconds north by, and this one gets a little bit more complex. 61 is too much. So we subtract that 60, that leaves us with 1 second. So that means we have to transfer that over to our 59 minutes. But it turns out that after we transfer that, then we are left with 60 minutes, which is also too much, because if we have 60 minutes, that has to be converted to 0, 0, and we have to add this hour, in essence, to the previous, or to the degree. So we're adding that number. So the correct answer is going to be 13 degrees, 0 minutes, and 1 second. So the final answer for this would be completely read out as 22 degrees, 50 minutes, 13 seconds north by 13 degrees, 0 minutes, and 1 second west. So As a quick recap, we are using the geographic grid, which is made up of lines of latitude and longitude. This is that network of intersecting lines that allows us to find absolute locations. Lines of latitude or flatitude are the lines that are running parallel along which includes the equator, and lines of longitude are the ones that run north-south. That includes the prime meridian. Both the prime meridian and the equator make up the 0 points that are the starting points when we are looking to identify absolute locations. Feel free to look through the rest of this PowerPoint. It is going to have additional information regarding lines of latitude and longitude, why they are called parallels. It is going to help you to identify important lines of parallels, as well as understand the difference between meridians and the prime meridian. So go ahead and review this PowerPoint, work through your practice labs, and then get to your graded lab. And remember that you can only get to the graded labs once you have successfully completed your practice labs with adequate scores. If you have any questions, feel free to reach out to me via Canvas inbox. Thanks.